In this problem, we're given two charges, a negative 5 coulomb charge and a positive 3 coulomb charge, and we're asked to find the magnitude of the electric force that B will exert on A. Okay, and for this equation, we're going to be using this equation. The magnitude of the force is Coulomb's constant times the absolute value of charge 1 times charge 2 over the radius squared. So this is an important equation that we're going to be using. Okay. So we know that Coulomb's constant is 9 times 10 to the 9. And our first charge is a 5 coulomb charge, and then we have another charge that's a 3 coulomb charge. And our radius is 3 meters, and we're going to square. Okay. And when we do this, plug this into our calculator, we get 1.5 times 10 to the 10 newtons. Okay. So that is the force that object B exerts on A. Okay. For the second part of this problem, we're asked to find the work when we move object A, or the charge A, to 10 meters away. Okay. So we're going to use the same equation, that the magnitude of the electric force is equal to Coulomb's constant times the absolute value of charge 1 times charge 2 over the square of the radius. So we need to find the force at 10 meters. And we'll use this to find the average force from 3 meters to 10 meters. So first let's find the electric force at 10 meters. Okay. So Coulomb's constant is 9 10 to the 9 times charge 1, which is 5, charge 2, which is 3. Okay, and then the radius will be 10 meters. Okay. And when we plug this into our calculator, we get 1.35 10 to the 9 newtons. Okay, and now we're going to try to find the average force. So force, electric, average, magnitude. Okay, so how we're going to do this is we're going to take the force that we had at 3 meters and the force that we have at 10 meters, and we're just going to find the average between these two. So 1.35 times 10 to the 9 plus 1.5 times 10 to the 10, and we're going to take this whole quantity and divide it by 2, and that's going to be our average force. And to find the work is force times the change in the distance. Okay. Then we're just going to take this value, our average force. So just bring this down and multiply it by the change in the distance. So we go from 10 meters from 10 meters is our final distance from 3 meters. Okay, and when we plug that into our calculator, we get 5.7 times 10 to the 10 joules. And that is our work.